Number 8, notice there's no leading coefficient. That means we can play the game of multiplying to 40 and adding up to 6. It's going to begin with y and y in the two parentheses. That 40 is 1 times 40. Nope, that doesn't make a 6. 2 times 20. 4 times 10. Bingo, 4 times 10. Now I want a positive 4 and a negative 10 to add up to make that negative 6. And I'm just double checking F, O, I, and L in my head. If you want to write out the 4y there and the minus 10y there, that's a good habit to get into as you're checking your work. Number 9 here. I do not see a GCF that goes into all three terms, but I'm going to continue to ask. Usually when I see a square at the beginning and a square at the end, that kind of tells me I'm going to have the same thing in both parentheses. I'm confident enough about that to kind of put it in pen here. 4 times 4 makes that 16, plus 3 and plus 3 multiply to make that positive 9 at the end. And looking in the middle, I have a 12x. Outer, I have a 12x. That makes the 24x. Okay, when the same thing shows up in both parentheses, we write it as a quantity squared. That actually has its own name. It's called a binomial square because you have a two-termer, a binomial, getting squared. Kind of obvious there. Number 10. We look at it, we see a p to the 4th. I'm not going to let that scare me. It just means I'll have a p squared in both parentheses. I don't see any prime numbers, and I don't see any greatest common factors that can be divided out. I'm going to start by trying the balanced approach, the 2p squared and the 3p squared, seeing if that works. Now with that 10, I'm thinking, oh, 1 and 10 actually do work. Whoa, no they don't work. Watch this. This is kind of neat. If I put a 1 and a 10 there, I get the 3 and I get the 20. And 20 minus 3 is 17. But in order to go 20 minus 3, I'd have to make that a minus 1 and a plus 10, and then the negative times the positive would not make that plus 10. So 1 and 10 doesn't work. 2 and 5, no. 5 and 2, no. Let me stop with this for a second. 5 and 2, if I put the 2 here and the 5 there, I get 10 and 6, close but no cigar. 5 and 2, no. Okay, sometimes we just have to play with these and see what happens. Let me see, maybe I should have gone with the 6p squared and 1p squared approach. 1 and 10 don't work, 10 and 1 don't work, 2 and 5 don't work. Hey, guess what? It's the last thing I try. 5 and 2. There's my 12 on the outer edges, and my plus 5 in the middle. 12 plus my 5 make the 17. So there, maybe it was good in this video that I showed you me struggling a little bit, trying all the different combinations, so that you can see that, hey, everyone has to do that every once in a while. And yes, it was the last thing I tried. Okay, number 11. Y. That's a GCF that can be factored out, leaving us with 3y squared minus y plus 12. Leave the y out front. I notice that 3 is a prime number, so that means 3y times 1y will be how it has to kind of go. Now as far as that 12 goes, it's probably not a 1-12 split. I'm going to try the 3-4 split. 3 and 4, no. 4 and 3, no. 2 and 6, 6 and 2. Okay, let me try this out slowly. 1 and 12. That gives me a 36 on the outer, and that's too big. 12 and 1. That gives me a 12 in the middle and a 3 on the outer. That doesn't work. 2 and 6 gives me an 18 on the outer and a 2 on the inner. That won't work. 6 and 2 can't work because that puts the 3 and the 6 next to each other, and that would mean a 3 can factor out. So I try 3 and 4, giving me 12 on the outer, 3 on the inner. That doesn't work. 4 and 3, 4 on the inner, 9 on the outer. That doesn't work. So guess what? I've tried every possible combination of numbers that multiply to make that 12, and none of them work, which means all we could do in this problem was take out a GCF, and sometimes that's all that happens in these problems. I'm sorry I'm leaving you on this video with an uncomfortable feeling, but that's the way it goes sometimes.